Hello students, welcome to Eduxcite classes. My name is Monit and in today's session we will discuss topic 7, that is your atomic, nuclear and particle physics. So without wasting time, let us start with the very first question. So very first question, the Giga-Martian alpha particle scattering experiment provides the evidence for the existence of. Now we know that the Giga-Martian experiment is nothing but the Rutherford Goldfoil experiment. Okay, so that alpha particle experiment gives us the conclusion for the evidence of nothing but the atomic nuclei. So all majority of the alpha particle just pass through the nucleus, which denotes that all the positive charge was to the atom, and all the positive charge was concentrated at the center, and that was considered as the atomic nuclei. So first question, option A is the right answer. Now for question number 2, again the same Giga-Martian experiment. The alpha particles are scattered by gold foil. We take a gold, the atom of the gold foil, and the thickness of that foil is very small, so that only one atom can align in a particular row. So when the alpha particles are passing through the gold foil, the experimental result indicate the most of the alpha particle we know that are scattered along only at a small angles, because majority of the uh, atom is empty, and you can say all the positive charge was, so alpha particle being a positively charged and all the positive charge were concentrated at a very small space, so majority of the atom was empty, so scattered only at small angles. Okay, so option A is your right answer. Now question number 3. The atomic line spectra of elements provides the evidence for the existence of. Now we know that the line spectra, either it may be an absorption or emission line spectra, it gives us the evidence of the energy levels, of quantized energy levels within the within the atoms, not nucleus, because we are talking about the elements existence. Okay, so it is within the atoms. Option D. Question number 4 now. Which one of the following correctly gives the number of electron, proton and neutron in a neutral atom of a nuclide copper 2965? Now we know that this is nothing but the proton, number of protons. Okay, and this is mass number, which is proton plus neutron. So neutron will be mass number minus atomic number, so 65 minus 29 is 36. This is the number of neutron. Proton is 29, and if it is a neutral, then electron will also be 29. So number of electron 29, proton 29, number of neutron 36. Option D is the right answer. Now question number 5. The number of nucleons in a nucleon. Now nucleon is a term that we generally use for the total number of protons as well as neutrons inside the nucleus. We call it as nucleon. So proton plus neutrons in the nucleus is nothing but the nucleons. Okay. Now isotopes provide the evidence for the existence of. Now you might know that isotopes. Now why I've written P like this is because it gives iso stands for same, okay, and P stands for proton. Now same number of protons but different number of neutrons are known as isotopes. So it gives us the evidence for the existence of neutron, that is option D for question number 6. Okay, if you have any doubt in any of the question, you can comment below. I will try my level best to clear all your doubts. Okay, now question number 7. The silver 102, 103 and 104 are three isotopes of the elements silver. Okay, now which one of the following is a true statement about the nuclei of these isotopes? Now isotopes, as we mentioned, that they all have the same numbers of proton. Okay, P stands for proton, iso stands for same, so same number of protons. So this is nothing but all have the same number of protons. Okay, now question number 8. Which of the following identifies the significant interactions between the nucleons inside the nucleus? Now we know that inside a nucleus we have what? Positive charge proton as well as neutrons. Okay, and they are very close interactions are there. So positive and positive, there will be a Coulomb force that we'll learn in topic 5, as well as there will be a strong nuclear force is also acting. Gravitational force here will be very very less because the masses are very very small. It is 10 raised to power minus 27 kg, like somewhat like in that range. So gravitational force is not significant here, although it is there, but it is not significant. It is asking you the significant interactions. So there will be only two forces acting between the nucleons inside the nucleus. That is, one is the Coulomb static force of attraction or repulsion, and the neutrons and protons are existing, and proton or neutron, they all, it doesn't depend upon the nature of charge for the nuclear force. So option C for question number 8. Now question number 9, the nucleus of an atom contains protons. We know this. The protons are prevented from flying apart by. Now this is a very common question, guys. You should think that we studied in topic 5 about that positive and positive charge repel each other. And now in this atomic structure of an atom, we say that all the positive charge is concentrated at the center. Now how is it possible that all the positive charge are there inside the nucleus? If we go in the higher atomic number, as we move to a higher element, higher atomic number, the number of protons increases, and we know that they all lie inside the nucleus. So how is it possible for them to overcome the electrostatic force of repulsion, that is the Coulomb force of repulsion? Because there are positive and positive charges, they will repel each other. So the answer lies in the strong nuclear force which dominate over the Coulomb interactive repulsive force. Okay, so that is the answer. So you can say the protons are prevented from flying apart because of the presence of strong attractive nuclear forces. So nuclear forces are always attractive in nature. Okay, so make a note of this. Now question number 10, it's a direct question. The unified mass unit is defined as. Now we know that the unified mass, when we go for the formal definition of atomic mass unit, it says that it is the equivalent to the 1/12 of the mass of one neutral atom of carbon 12. Why we have taken carbon? Because carbon is present in almost each and every matter that is existing on this planet Earth, majority of them. Okay, so we take a reference of carbon so that it makes us easy for us to compare. Okay, so the atomic mass unit is defined as the 1/12 of the mass of one neutral atom of carbon 12. Okay. Okay, now question number 11. Which of the following best describe why alpha particle travel only a short distance in air? Now you should know what is the nature of alpha particle. Now alpha particle is what? It is similar to the nuclei of a helium atom. Okay, like this. Now you can see it has a nuclei. Nuclei means it has a positive of two protons and two neutrons. Okay, now it is quite heavy as you compare to the other alpha other type of decay radiations. Okay, so it is heavy as well as it is having a +2 charge, so it has a more ionizing, so it ionizes the air, therefore it can only travel through a short distance in air. So the option is 3 only. They ionize the air molecules because they have a +2 charge. So when they passes through the air, they ionize the air around the alpha part when the alpha particle is passing through the air. Now question number 12, a nucleus of the isotope potassium thus decays to form a nucleus argon 40. Which of the following correctly identifies the other two particles resulting from this decay? Now whenever you got such type of questions, it's quite easy. Like you can think how the number of protons and the neutrons are changing. So if I say like this isotope, let us say potassium 40 and this is 19, it decays to form argon whose atomic mass number is same but atomic number, now you can see it decreases by 1. So this has to be a beta +1 and this should be 0. So this should be like this only, then only the atomic number on the left hand side will be balancing out with the right hand side. If it is not balancing, then it is not possible for that particular reaction to take place or the decay to take place, guys. The charge number, the mass number, the strangeness number, you might have heard in the 7.3 about the particle physics. So they all are supposed to be constant. Constant means on the right hand side should be equal to the left hand side. Okay. So for here you can see -1. So beta plus will be there. So A is incorrect, B is incorrect. Now we have to think about C and D. Now whenever there is a beta plus, that is not nothing but positron. We call it as positron. Okay. So it is similar to electron, just with an opposite nature of the charge. So beta plus, that is fine. Now with beta plus, what should be the antiparticle? It will be it will be the electron neutrino, which is C. This will be with beta minus, but here it is not beta minus. So option C will be the right answer. Now question number 13 again. It is similar. This is a nucleus 3015p undergoes to form 30 silicon 14. Again it is a decrement, so there will be beta plus, okay, 1 0 emitted and positron with a neutrino. So again a positron and a neutrino. Option C will be the right. It is similar to the above question, just in the form of they have given the options in a form of a wordings. Now question number 14. In a laboratory where aluminium nuclei are bombarded with alpha particles. Now read the question very carefully. In a laboratory we are doing, and that too aluminium nuclei are bombarded with alpha particle, this reaction takes place. Now this reaction is an example of, now fission means a heavy nuclei splits into a two lighter. So this is not happening. Fusion means two lighter nuclei fused together. Now these two are not lighter. Okay, I agree, helium is a lighter nuclei, but aluminium is not a lighter. So we are forcefully doing this in a laboratory condition. So it is nothing but an artificial transmutation. Those who don't know, it is given in your reference book of Cambridge Toscos. Okay, so artificial mutation, it is defined as, you can say, it converts, those who don't know can write down, it converts an element into another element. It converts an element into another element by bombarding it with a fundamental particle. And for this, the kinetic energy of this alpha particle should be higher than, in order to make the nuclei changes into another element. Okay, so if this kinetic energy is not sufficient with the alpha particle, then this will not take place. Okay, so this is nothing but artificial transmutation. I hope it is clear. If you have any doubt, you can just comment below. Now question number 15. K capture is a process that occurs when a nucleus captures an electron from an innermost shell of electrons surrounding the nucleus. Okay, we have different shells, K, L, M, N. So K is the innermost shell. When K captures an iron, the nucleus is changed into manganese nucleus. Which equation represents this change? Now again you can just check. Now look here. This is 26, this is plus 1, this is 27. Okay, so this is a process which satisfy on the right hand side as well as on left hand side. This also satisfy, but you can see here this is 55, this is 0, this is 55. Now here it is 56, sorry 55, this is 1 and this is 57. We know that electron number mass number is not there, so this option is incorrect. Okay, now look here, 26 minus 1, 25, 55 0, 55, this is possible. 55 26, this is again impossible. So we have to think that electron, now it is saying that an electron from the innermost or surrounding the, that when a nucleus captures means it takes the electron. Now this is positron, this is electron. So only option C is the right answer. Read the question. It is saying that a nucleus captures an electron. So this is the nucleus of iron. So it will capture, it will absorb the innermost electron. So electron is having a charge of -1, not +1. Okay. So this will be the only answer. Now question number 16, if you see, an isotope of aluminium bombarded with again an alpha particle X, we don't know, an unknown element with a neutron. Okay, now what should be the proton number and nucleon number of X? So if you see that, neutron will be written as what? Neutron will be having no charge, like this. So this is 27 plus 4, which is 31, and there is 1 here, so this will have a mass number of 30. So only this option. And proton number you can check, 13 plus 2, so this will be 15 and this will be 30. So option A is the right answer. Okay, very easy. So now the binding energy per nucleon. This is the most important concept from this topic, the binding energy per nucleon. Please go through in detail what do you mean by this concept of binding energy per nucleon. It is nothing but the minimum amount of energy required to split the nucleus into its fundamental particle apart, because they are strongly interacting with the strong nuclear force. So in order to break the nucleus, you have to provide a certain amount of energy to it. So that energy per nucleon, like for example, if I say there are 30 number of nucleons, and if I have to provide 30 joule, let us say, just a simple example so that you can understand it better. So 30 joule is required to break an element having a 30 number of nucleon. So binding energy per nucleon will be number of nucleon, total energy divided by number of nucleon. So 30 divided by 30 will be 1. So I need 1 joule of energy to you can each nucleon to split apart. Okay, so let's get back to this question. So this is the nucleus of lithium is approximately 5 mega electron volt. Okay, so this is the per nucleon it is given. It is not the total energy that is required. It is for one nucleon of lithium element, lithium nucleus, we want 5 mega electron volt approximately. Now it is asking you the total energy required to completely separate the nucleons of this nucleus is approximate. So how many nucleons are there? That is 7, and 1 required 7. So total will be how much? Total will be nothing but 7 into 5, which is 35 mega electron volt. Option C. So this is the easiest way to answer this type of question, and this is very common, guys. Now question number 18, this graph is quite very important. The graph below illustrates the variation with nucleon number n of the binding energy per nucleon. So this is binding energy per nucleon, E of the binding energy per nucleon, E of nuclei I having a mass number n. So which of the labeled nuclei is the most stable, guys? Now in terms of most stable, always remember this: higher the binding energy, this is the golden statement, higher the binding energy per nucleon, more the element, or you can say the nucleus, is stable. Because you have to just understand one thing, that if I have to provide more energy to break the nucleus apart, it means that nucleus is more stable. So you can see among the given option, C is the one which has the maximum binding energy. Okay, so option C will be the right answer for this case. Question number 18. Now question number 19. A freshly prepared sample of cobalt 64 decays by the emission of gamma ray photons. The decay may be represented by this equation. So we know that a gamma ray is just a emission of energy in a form of photon HF. Okay, so there is no change in either the nucleon or the atomic number. So after this decay, the binding energy. Now we know that when the energy is released out, the energy, why gamma radiation takes, in order to become more stable, So if the atom, or sorry, if the nucleus is becoming more stable, it means the binding energy will increase, because you have to provide now more energy in order to break apart. It's very conceptual, guys. Listen very carefully. I'm saying it once again. Gamma ray, if it is emitted in the form of energy, it is taking out. So gamma radiations are emitted in order to make the nucleus more stable. If the nucleus is becoming more stable, the binding energy will increase. So you can say there is increase in magnitude because the energy has been emitted from the nucleus. So option A will be the right answer for this question. Okay, so it is asking you the binding energy per nucleus has increased, not decreased. It will not stay constant. So option A will be the right answer. Okay. Now question number 20. Two light nuclei of mass m1 and m2 fuse in a nuclear reaction to form a nuclear mass of m. So whenever an two nuclei fuse together, there is a release of energy, and that energy is m1 plus m2 gives m plus energy. Okay, now this energy come because of the mass defect. So definitely this mass will be less than the summation of the m1 and m2. So only option B satisfies this. So for question number 20, B is the right answer. Okay, now question number 21. So you can see there are two hydrogen nuclei fused together to form helium with a emission of neutron. So it is nothing but the fusion only. It takes place. It's not a artificial transmutation, because if you provide, it is a natural and it takes place in the surface of the sun also. So it is not a artificial, but it is a nuclear fusion only. Now question number 22 is quite a good question. A graph below shows the variation of mass number, nucleon number of the average binding energy per nucleon. So you can say the directions of 1, 2, 3 and 4. Which direction indicates a fission reaction? Now fission reaction means a higher nuclei splits into a lower nuclei. So definitely the mass number will decrease. So first we have to go with this arrow. So option 3 gets over and option 1 gets over. Now we have to think 4 and second. With the release of energy, now guys, fission reaction takes place when a higher, so higher is this only. Okay, they are already the lighter nuclei, so this is not going to happen, and here you can see the binding energy is decreasing. No, it cannot take it. It always happens in such a manner the binding energy increases, because everybody wants to become more stable. So option 4 will be the right option D. The fourth one, the arrow going this side, will be the right answer. Okay, fine. Question number 23 now. Rest mass of lithium is given ml, the rest mass of proton is mp, and the rest mass of neutron is mn. The speed of light is this. Which of the following is correct expression for the binding? Now we know that binding energy is delta m into c square, and delta m is nothing but the difference in the sum of the fundamental nucleon mass number with the mass number of the nucleus. Okay, so individually how many there are protons? 3 mass of proton plus 4 mass of neutron. These are the sum of the fundamental masses of lithium nucleons. This minus mass of the whole neutron, this is the mass defect into c square. So if you look at the option, you will get only option A as the right answer. Okay guys, so guys, if you have any doubt, you can comment below. Also the PDF, whatever I'm annotating in this video, you can download the PDF. The link is given in the description below. Okay, now question number 24. The source of sun's energy, everybody knows this, fusion, nothing to just worry about this. Question number 25. The radioactive decay process is a random process. Now why it is a random process? Because we cannot predict what type of decay will takes place when. Okay, so we cannot predict when a particular nucleus will decay, and that is why it is known as a random process. Now question number 26, half-life. Now half-life is another important concept from this topic. Many times they have asked questions. So there is a half-life T half for initially containing n atoms. Which one of the following gives the number of atom of that isotope that have decayed after 3 half-life? Now let us say initially it was n. So after first half-life there will be n by 2 remaining inside the nucleus. Now guys, these are the remaining, okay? Do not get confused here. Majority of the students do this mistake. These are the remaining inside the nucleus which are about to decay. It is not the number of nuclei decayed, it is remaining inside the nucleus. This is the first half-life. After second half-life it will be this, and after third half-life the remaining will. So this much amount is remaining inside the nucleus. So how much it will be decayed till now? So from, you can say, from n to n8, how much it is decayed? N minus n by 8, because initially it was present. After 3 half-life this was present, so the decayed will be 8n minus n by 8, which is 7n by 8. So option D is the right answer. Okay, so this is very important concept, guys. Do not make this mistake. Majority of you will do option A, but that will not be the right answer. Question number 27. A nuclide X has a half-life 10 seconds. So 10 seconds is the half-life for X. On decay, the stable nuclei Y is formed. So after decay, Y is formed. Initially, a sample contains only X number of atoms. Okay. So after 87.5% of the atom in the sample have decayed into nuclei Y. At what time? Okay. So let us say initially the X is 100%. So after one half-life it will be 50, then it will be 25, then it will be 12.5. so you can say initially it was 0, now it was present 50, now it was present 75, now it was present 87.5. so this is the decayed process, how much is decayed, and this was the remaining that are supposed to be decayed. So you can say after, this is the first half-life, this is the first, this is the second, and this is the third. So 3 half-life it takes to decay 87.5%. So 3 half-life. So 1 half-life is equivalent to 10 second. So 3 half-life will be 3 into 10, which is 30 second, option B. If you don't get it, you can just reverse back the video and you can watch it again. This is very important, guys. And the last question of the day. A sample of the material contains 64 microgram. Okay, initially how much it is there? After 60 minutes, okay, it becomes, after 60 minutes it becomes 2 microgram. How much? 60 minutes it takes. The half-life, now for 64 it will, how much it will take? From 64 it will go to 32. This is the first half-life. Then 32 to the half, that is 16, second half-life. 16 to 8, third half-life. 8 to 4, fourth half-life, and 4 to 2, fifth half-life. So total, you can say, number of half-life is 5, and it takes 5 half-life for 60 minutes. Okay, so just a second, if you are not able to see it, this is what I am saying. So total number of half-life is 5, and for 5 it takes 60 minutes to reach 2 microgram. So one half-life will be, its half-life will be equals to 60 divided by 5, which is 12 minutes. Option B will be the right answer. Okay, so I hope I have cleared all your doubts related to topic 7. Even though if you have any other doubt, you can comment below. Okay, you can download the PDF also, it is given in the description. Thank you, keep learning, see you in the next video.